Hello dear student, I am Dr. Samadhan Munde, Assistant Professor and NSS Program Officer, Department of Mathematics, Sri RLT College of Science, Akola. On behalf, on behalf of Department of Mathematics, I welcome you all in e-Pathshala online class in the session of 2020 and 21. So, dear student, in previous lecture we have started complex analysis subject. In last lecture we have seen some basic concepts of the complex analysis that are required to review of our knowledge. So that's why we have taken some introduction part of the complex analysis, or we can say that some basic concept of the complex analysis. That basic concept you already learned in BSc first year, second year as well as third year. So just we have taken a brief introduction, or we can say that brief basic concept of the complex analysis. So today's lecture we will start unit number 1 of the complex analysis, and that unit number 1 is a complex integration. So in this complex integration unit, we will see the first introduction part of the complex integration, or we can say that some basic concept of the complex integration. So first we will see some basic definitions, or we can say there are some required definition in a complex analysis. So what is the first definition? What is the first definition is a curve, or we can say that the uh, path, or we can say that it is also called as a continuous curve. Okay, we know that generally any bending line, that line is called as a curve line. Okay, so that not should not be a straight line. Okay, so if there is any bending line such that line, so this types of line is called as a curve. Okay, so what is the mathematical definition of the path or curve? A path in a complex plane C. In previous lecture, we already seen this symbol, that is a complex plane C. Is a continuous gamma. Gamma is a curve from a closed interval A to B, where A less than B, where A and B belongs to R into a complex plane C. Okay, so let us suppose that this is a complex plane. So this is a complex plane. Let us suppose that this is a complex plane. Okay, and this is a curve from A to B. So this is a A point and this is a B point, and that curve name is a gamma curve. Okay, so this is a gamma of A and this is a gamma of B. So here gamma of A is a starting point and gamma of B is a ending point. Okay, when we have already seen A less than B, the starting point always less than ending point. Okay, that means we can say that the starting point always less than ending point. Okay, so here gamma of A is a starting point and gamma of B is a ending point. Okay, or we can say that gamma of A and gamma of B both are the first is the initial point, or second is the terminal points. Okay, so here gamma of A and gamma of B are called as the initial and terminal points respectively. Okay, so this line is called as a curve, that is a gamma curve, and initial point is gamma of A and ending point, terminal point is gamma of B. Okay, so you can draw the any types of curve. Okay, so this is the simple definition of the curve. Now we will see trace of the curve. What is the trace of the curve? If if the gamma mapping it AB tends to C is a path, then the set gamma of A, gamma of D, A less than equal to T less than equal to B is called the trace of gamma, and it is denoted by curly bracket gamma. Okay, so this curve is denoted by, so this curve is denoted by the mapping gamma AB. So these are the initial and ending points. In this region, we will define this curve. Tends to C in a complex plane C is a path. Then the set of gamma of t, the set of gamma of t where a less than equal to t less than equal to b. Okay, such that gamma of t such that a less than equal to t less than equal to b. So this is called as the trace of the curve gamma, and it is denoted by the in curly bracket gamma. So this is the definition of the trace of the curve. You already learned in BSc third year. Now we will see the next definition, that is the rectifiable curve, or we can say the rectifiable path. Okay. So what is the rectifiable curve? Simple definition: if gamma AB tends to C be a path, if length of gamma of t, if length of gamma of t is a finite for the interval a less than equal to t less than equal to b, then gamma is said to be a rectifiable path, or we can say that rectifiable curve. Okay. So here gamma of AB tends to C, here gamma is any curve whose points whose points AB in a complex plane C, if the length of gamma of t is finite. Okay, if the length of gamma of t is finite, then that curve is called as a rectifiable curve. Okay. So how the t lies between a less than equal to b less than equal to p. So t always lies between a and b. Okay. So this is the rectifiable curve. Then we will see the continuously differentiable, which function is called as a continuously differentiable. A path is said to be a continuously differentiable if the function gamma of t, if the function, let us we consider the function gamma of t equal to x of t plus I gamma of t, for t belongs to closed interval AB, is continuously differentiable on a closed interval AB. That is, x dash of t and y dash of t exist for each t belongs to AB and are continuous function of t on closed interval AB. Okay, when we say that the given function is a continuously differentiable function, if the gamma of t equal to x of t plus I y of t for t belongs to AB is continuously differentiable on a closed interval AB. Okay, suppose that this gamma of t is a continuously differentiable in a given range. Range is a and b. Okay, so that means there exists its derivative, that is x dash of t and y dash of t in interval AB. Okay, and that derivative is a continuous and that derivative functions should be the continuous on that interval AB. Then we can say that that function is a continuously differentiable. So here we have to note that gamma of t is a differentiable on a closed interval AB, means that gamma uh, gamma dash of t exists on open interval AB. We already seen a derivative of that function should be exist in that closed interval AB. So here gamma of t is differentiable in open in closed interval AB. The meaning of this derivative of gamma of t exists on a open interval AB. Also, gamma dash of t, derivative of gamma of t not equal to 0 on a closed interval AB, then gamma is called as a smooth curve. So this is the definition of the smooth curve. When we what is the definition of the smooth curve? Let us consider the function gamma of t equal to x of t plus I y of t for t belongs to AB is continuously differentiable on AB. Okay, if gamma dash of t is not equal to 0 in the closed interval AB, then that gamma is called as a smooth curve. Okay, so this is the definition of the smooth curve. Now we will see the next general definition of the limit. You already know the definition of the limit. Okay, you already learned in BSc first year, second year and third year. So again we will repeat this definition because this definition is useful in our theorems as well as problems. So let f be a real valued function defined for all z in the neighborhood of the point z0. Let us suppose that z0 be the any point uh, who is the neighborhood of z, except possibly at x0 itself. So let L be the a real number, then limit z tends to z0 f of z equal to L. If for every epsilon greater than 0 there exists delta greater than 0 such that 0 less than absolute value of z minus z0 less than delta, which implies f of z minus L less than epsilon. So this is the definition of the limit. Okay, we will not go to deeply because you already know the definition, limit, continuity and differentiation. Okay, so just we are overlooking on this definition because this definition we will use in solving problems as well as to in a proof of the theorem. Second definition is a continuity. What is the continuity? A function f of z is said to be a continuous at z equal to z0 when if limit z tends to z0 f of z equal to f of z0 for any epsilon greater than 0 there exists delta greater than 0 such that absolute value of z minus z0 less than delta, which implies mod f of z minus f of z0 less than epsilon. So this is the definition of the continuity. Okay. Now we will see the next definition, that is a differentiation. What is the differentiation? You learn in from so these definitions you are learning from 11th and 12th standard. Okay. So what is the next definition? Next definition is a differentiation. What is the differentiation? So let us suppose that f g to c, here f is any function, g is a region and c is a complex plane C. We are we are in a complex plane C is a differentiable at a point z0 belongs to G, where z0 is any point in a region G. Okay. So I would like to clear here. So here f is any function, G is a region, G is a region and C is a complex plane. Okay, complex plane. Okay. So is a differentiable at a point z0 is any point in a region G if limit z tends to z0 f of z minus f of z0 divided by z minus z0 exists. If the limit is exist in this region G at a point z0, then 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 we can say that f of z0 is a differentiable function, or f is a differentiable function, and it is denoted by f dash of z0, and it is written as mathematically f dash of z0 equal to limit z tends to z0 f of z minus f of z0 divided by z minus z0. So this is the definition of the differentiation. Okay, in a complex plane C in a region G. Okay, at a point z0. Now we will say, when we say that the given function is a continuously differentiable function. Now we will see the definition of the continuously differentiable function. So let us suppose that f is a f of z, or we can say that f is any function in a region G in a complex plane C. So f g to c is a differentiable function at a z0. Z0 is any point, and f dash of z0 is a continuous for every z0 belongs to G. Then f is said to be a continuously differentiable function. Okay, when we say that if the f of z is a if f of z is a differentiable function at a point z0, okay, and f dash of z is continuous for every z0 belongs to G, at every point f of z is a differentiable, then that function f is said to be continuously differentiable function in that region in a complex plane C. If f dash is a differentiable, then f is a twice differentiable continuing this way. Okay, what is the meaning of this f dash? F dash means double derivative of the f of z. Double derivative of the f of z. F dash is a differentiable when we say that f is a differentiable function, that means f dash of z, there exists f dash of z. Suppose that f dash is a differentiable function, then we can say that f is a double differentiation. That means f double dash derivative exists. If f dash is a differentiable, then f is a twice differentiable. Continuing in this way, a differentiable function such that each successive derivative is again differentiable is called as a infinitely differentiable. If you take the derivative of again and again and again and again, so that derivative is called as a continuously infinitely differentiable function. Okay, so we know that the how many numbers in this universe: 1 2 3 4 0 1 2 3 4 5 and 6 and so on. Okay, there are infinite numbers. Okay, so in this way we can differentiate. If the function is a differentiable, then in this way we can differentiate infinitely. So that function is called as a infinitely differentiable function, if the function is a differentiable at all. Okay, so now we will see the next definition is a complex integration. Now we are towards our unit number 1. Okay, what is the complex integration? Okay, so if f a b tends to c is given by the function f of z u of t plus I v of t, where t lies between, where t is in closed interval a b, then integral a to b f of z dz equal to integral a to b u of t dt plus I integral a to b gamma of t dt. Okay, so this is the complex integration. Okay, so what we have done here, so just we have take f of z is a any function, f of z is a any function in a complex plane C. Okay, in region in interval AB, f of z is a any given function in a uh, in interval, in closed interval AB in a complex plane C, and that function is given by f of z equal to u of t plus I v of t, or we can say the gamma of t, where t lies between in a closed interval AB. Okay, so then taking the integration on both side in closed interval a to b, limit should be the a to b. So integration a to b f of z dz. So you have to integrate this function in between a to b. So integral a to b f of z dz equal to a to b u of t dt plus I a to b, a to this is a b, a to b v of t dt. Okay, so we can say that we can write in this way. So this is the definition of the complex integration. Now what is the line integral? What is the line integral? What is the line integral? If f g to c, where g is a sum region and gamma is a curve in a region g, defined on gamma a to b tends to c, lies inside g, then integral over gamma f of z dz is called as the line integral. Is called as a line integral. When we say that line integral, f of z is any function in a region G in a complex plane C, where G is some region and gamma is any closed curve which is defined in a region G, and that gamma curve is defined as gamma of AB tends to C lies inside in region G. If that gamma curve lies inside the region G, then integral of the over f of z, then integral over gamma f of z of this function f of z is called as a line integral. Is called as a line integral. Or here we can say that here the variable z transfers along the curve gamma from gamma of A to gamma of B. It is also called as a Riemann Stieltjes integral. Okay. So we have already seen the definition of the gamma. gamma of t. Okay, so there are gamma of a and gamma of b are the initial and terminal points. So this is the important result in a complex integration. Integral over gamma f of z dz equal to integral over gamma f of gamma of t into d gamma of t into gamma of t. So that means here we have put up z equal to gamma of t. So this can be written as a to b f of gamma of t into derivative of gamma of t means gamma dash of t dt. Okay. So here z equal to, here we have put up z equal to gamma of t. Okay. So this is the most important result. So these all the basic concept of the unit number 1, complex integration. Okay, so in next lecture we will see some problems on this line integral or complex integration concept. Okay, so we will stop here. So in next lecture we will see some problems on this topic.